Welcome to another Study Session Tuesday here on the Cyber Insecurity channel. Thank you for joining us for our 12th episode of the Intro to Python series. Yes, this is supposed to be a 12 episode series, but we went long on chapter 10, so it'll actually be lucky 13. So again, my name is Brent Eskridge. I've been a software developer, a computer science professor, and now a threat intelligence analyst. And I've programmed everything from shell scripts to a network server to simulations that run on supercomputers. So I've made lots of programming mistakes, and I like to help people learn how to program and make completely new programming mistakes. If you'd like to connect with me on the socials, you can use !Brent, and it'll list Twitter and LinkedIn. Make sure you follow me on Twitter for, I guess, next week's the last algorithm of the week, but I'll probably start posting some other sorts of things. If you want to connect with me on LinkedIn, I'm happy to connect. If you just send me a message or a note when you connect, letting me know what you've been getting out of this series, I'd appreciate it. I want to thank our moderators for being here. We have a zero tolerance policy on toxicity on the Cyber Insecurity channel. We want this to be a positive learning environment for everyone, and moderators are here to ensure that happens. If you're put on a timeout or a ban, talk to the moderators about it in our Discord, which you can use !Discord to see that. So moderators are not here to stifle chat. They're here to ensure you get an opportunity to learn and ask questions. So I really value your questions. I think that's where the benefit of a live stream really comes in. But we do have a few rules. First, ask your question once and only once. The moderators do see your questions and will send them to me. I'm not allowed to look at chat, so I can't answer it directly. I'll try to answer the questions as quickly as I can. But if you're asking a question that I'm going to cover something in a few minutes, I'll kind of wait for that. Or if it's something that's not really relevant to what we're talking about, I'll probably just save it to the end and make that kind of in our wrap up. Second, there are some questions I just can't answer on stream, such as, your Python installation isn't working, or the code you're typing in and following along with, it just isn't working. So it isn't really practical for me to answer it here on stream. So if you go to our Discord channel, there's an Intro to Python study room. You can hop in there and ask your question. There's a number of people that are paying attention to that while we're streaming, and they can answer your question. If it's after the stream, I'll jump in as quickly as I can to help and answer it. The great thing about the community is, though, that we have so many people that are willing to help that a lot of the time the questions are even answered before I can get in there. So feel free to just post that in there, and we'll get you some help. As a reminder, this series is based on content from my university Intro to Computer Science course. It's the same content, just no exams, homework, that sort of thing. There's no prerequisite knowledge for the series, except for episodes 1 through 10 or 1 through 11 at this point. We do use some basic math examples. We've been most of those through that, so we won't hit that at this point. But we do have those dreaded word problems, which, no one likes a word problem, but unfortunately life is a word problem. But we do focus on those easy to define ones, specifically ones that if I were to give you a pencil and paper, you could complete it on your own. So it's not like they're super challenging. The problem itself, the challenge is translating that into an algorithm and then implementing it in Python. So also, there's a GitHub repository where all the content for this series is, and it's all free. There are basically the equivalent of my lecture notes in Jupyter Notebooks. There's supplemental resources, so videos, other books, things like that. I know it sometimes helps to hear something new when you're learning it in a couple of different ways, so that's in there. There's also some supplementary exercises that if you just kind of want to do homework, I guess, or if you want to push yourself, there's some of those there too. You can find the repository at !Intro to Python, and it'll list it there in chat. There's also a link to the book, so you can download it for free. It's called Think Python. You can download the PDF. or if you want a paper copy, you can buy it from your favorite bookstore. Again, I'm not affiliated with the author in any way. I've just found it of great benefit, and my students, when I taught courses, they found benefit in it as well. So I just put that out there, and feel free to grab it. So as always, we start off with the stream with an algorithm of the week. So I posted on Twitter. So this week's algorithm was, given two strings, find the longest common substring. So for example, if we did like, where is the substring, and I like sub sandwiches. The longest, or here, I like, let me change that. The sub sandwich my mom makes. All right. So the longest common substring here would actually be the spaces, space on this side of the, and then sub, right? Because we've got that. So we need to come up with an algorithm to find that. So again, these are easy to define problems. So the problem statement is exactly the same here as the one I've written out. Preconditions, remember, this is what's got to be true at the beginning before we start our algorithm. So our preconditions are, we are given two strings. Now, we've said, one of the things we've talked about is, when it's lists or strings, do we allow an empty list, or in this case, an empty string? In this case, we're going to allow it. So we're not going to put any limitations on the strings themselves. Post conditions. So this is what's true after the algorithm is run. So we can make it a return statement. So it's like a function. The longest common substring is returned. Right now, in this case, in the example I gave, there's a common substring. It could be that there is no common substring, and so that would just be the empty string is the longest common one. All right, so let's start looking at our algorithm here. Oh, by the way, I've just been notified that the bot commands in chat aren't working, so all the exclamation points aren't working. So I didn't program it, so it's fine to complain about the bot. So we can figure it out, and we'll get the links and things like that in there. So let's talk about the algorithm. So remember, we're going to return something, so we need to define what the longest common substring is. So we'll just default to the empty string. Default to the longest common substring is the empty string. That way, if we don't find anything, we've already got it. Okay. So, and then next we need to figure out, how we're going to do the comparisons. Well, we can help ourselves here. That we're going to essentially look through the letters from one string, or the characters from one string in another, right? So the longest common substring, the maximum length, is actually the length of the shorter string, right? So if we've got, let's see if it'll show it on my display. All right, so there are 24 characters in this string. That's the max length of the longest common substring, right? It can't be 26 or 27 because there aren't that many characters. So let's just start off, and we can call it the shorter string, the shortest string and the longer string. All right. So what we need to do is we can start with the shorter string, and we just need to walk through and first of all see, are there any capital W's, right? If there are, well, then we can go on to the next one. Well, here there aren't. So we'll go on to the next letter of an H. So we can go through here, and I see an H. Okay, so that matches. So let's see, does an E match too? Well, in this case, no. So then I need to keep on going and look for more H's. I don't see any, so I have to go to the E. So I can go here. I've got an E. Is the next one an R? No, it's not. Okay, so let me go find the next E, and so on. So what we're going to do is we're going to iterate through the characters in the shorter string. All right. Now, remember, I'm going to kind of talk about implementation here, even though the algorithm is supposed to be implementation dependent, but I want us to kind of think about this. We're going to have to, remember when we talked about iteration, especially like on strings, we talked about two different ones, right? So there's a for loop where we could just grab the character and go, or there's the for loop where we could get the index and then get the character. And the difference was really, do we need the index? Well, if we're going to be going through and let's say, you know, here I've got this E and I need to find the next letter, I'm going to need to go and find that next index. And so we're going to, when we actually implement this in Python, we need to use the one where we have the index. So that's going to be very important. So the next step here is we have to iterate through the characters in the longer string, right? And then in here we need to see, does the current letter or character from the shorter string match the one from the longer string? Right, I'm going to do a manual word wrap here. And so the question is, if it does, okay, yes, check the next letter in the shorter string and longer string to see if they match, right? And so we've got to keep on doing that. And so I can kind of, if I write it like this, it's kind of going to just, you know, we're going to draw a design with our code where it kind of goes back and forth. What we'll probably want to do at some point is make this recursive, right? To where it can go through, but I don't want to do that too quick here because I think that may be kind of confusing. And so I can do another one, and let's see, what's the next? I guess it's going to be a lowercase I. If it is, yes, continue comparing letters, right? And as we're going, we need to be saving these, right? And so we could be saving, checking to see if it's longer than the current substring. So let me go through. So we're going to make that a B. Actually, it'll be a C. So yes, and then we need to check to see, I'll make this a little bit longer here, is this current substring longer than the previous longest, which at this, when we start off, it's going to be the empty string. If we say yes, save this as the current longest substring. And so we can keep on going, and we're going to check if it is. We keep on doing, so you can see where the recursion is going to pop up. If at some point it says otherwise, meaning they don't match, go on to the next character in the longer string. So let's kind of walk through a little bit of what this would look like. So we're going to default to the empty string. We're going to iterate through the characters. So the first one, we're going to look for a capital W. Does the current letter from the shorter match a capital I? No. So we're going to go on to the next character in the longer string. So we're going to go through all of these, and none of them are going to match a capital W. So then we're going to hit back up here and go to the next character in the shorter string, which is an H. And so we'll start looking through here until we get to this H. And so, yes, it's a match. So at this point, H is longer than the the empty string. So we're going to save H as the new longest one. And we're going to save it, and we're going to check to see if the next letter, the E, matches the space. And it doesn't. So we're going to keep on going on. Eventually, we're going to get through here. We'll hit the E. We'll find a number of matches, but none of those are going to be longer. Actually, yeah, not on this one, but we are going to get to the point where an E space is going to match that. And so that's 2, right? And so we'll keep going through there. And eventually, we'll have worked all the way through, and we just return the longest common substring that we found, right? So recursion would come in here in that if we're going to start looking, we can look in this. So we could pull it up to a different function. We could find a way to make it recursive. There's a variety of ways that we need to expand on this continue comparing letters, right? So if I were, grading an assignment and it said continue comparing letters, I would say how, right? So we need to dive into this. Unfortunately, we're a little pressed on time. We've got to make it through the entire chapter tonight, so we don't have time to dive into this. So I'll leave this up to you. But this is the skeleton of it. And the idea is we're just going to continue the process. And so how would we write that so we're not just keep on doing letters and a massive if-then statement, right? Because we want to be able to handle however long the strings are. So I'm going to leave this as a homework assignment for you. Hopefully this kind of got you on the right track, so you've got an idea of what's going on here. Okay? So let me take a drink here real quick. And let's dive into code. By the way, if someone wants some more help on this, feel free to hit me up in Discord and we can talk about it. I'd love to go into more detail. I just feel a little pressed for time at this point. All right, so tonight we're going to talk about dictionaries. Now, you may be thinking, okay, this can't be the same thing as an actual dictionary with words in it and stuff. It actually is. Now, we're not necessarily going to be doing words and definitions, but it's the same concept. So I want to throw out, so a dictionary is a mapping between keys and values. So just like an actual dictionary is you have the word and the definition, the word is the key and the definition is the value. So they're called key value pairs. So you might have heard that. So it's also the same as a phone book, right? So name is the key, the telephone number is the value. So dictionaries are known by lots of other names. Some of them, so for example, it's also known as a map data structure. So that's very common. And then you start getting into certain programming languages have different names for them. So you may hear it called a table. I know Perl calls it a hash. Sometimes they're called hash tables. Perl also, I've done a lot of programming in Perl, calls it an associative array. So an array, but instead of numbers being indexes, it's anything you want. So dictionaries are very useful. One of the things I've found in my programming is that a lot of the times when I was doing a lot of programming, especially for research, I had a lot of things, so they were simulated robots that I would normally keep in a list. But sometimes I need to be able to access them by ID. That would be the key. So I started using dictionaries almost exclusively because one of the things is I can get all the values as essentially a list. In this case, it's going to be just a sequence, which is going to, in effect, work the same as a list. But I can do all the list stuff I need plus more. So that's why I started using hash tables, dictionaries, maps, whatever you want to call them. So let me give some examples here so you can see what we're talking about. So for example, I have we'll go to the lists as a refresher for lists. So remember, this was a list. And so I could print, what was it, index 1. So pause here for a second. I want you to figure out which one was at index 1. And it's the 2. Remember, we start counting at 0, right? And I could also, if I wanted to, store a value in here because lists were mutable. And I could now change it and put 42 instead of the 2, right? So dictionaries are going to work very similar. It's just that instead of a number and it being automatically assigned, we define what that key value is, or I mean, if you want to call it an index, right? So I'm going to create an empty dictionary, and I'm going to call it birthdays. And so I can print birthdays. And you can see it's empty here. So I could have also created an empty dictionary just using the curly braces. So the square brackets are lists and curly braces are dictionaries. So I can add values to it just like I did with a list using the same sort of notation. So I'm going to add the key value pairs. So I've got birthdays, right? So in this case, the key, or the index, if you will, is a string. Now it could be anything. I could have used a number. You don't really want to use floats. You technically could, but remember those are approximate, and so the odds of getting that correct are going to be low. But you can do other types of data too, which we'll see at one next week called a tuple, which you could if you want to. All right. So now I've got it in here. So let's print it out what we've got. And you can see it's got it in there. And so it has the key and then a colon and then the value. Now, a couple of things here. First of all, there is no implied order in a dictionary. So, say, but wait a minute, dictionaries are alphabetical, right? So that's an actual dictionary or a phone book. Those are alphabetical. The reason they're alphabetical is so it makes it easier for us to search through it. Dictionaries use a different kind of organization. There's a number of them. The most common one is using hashing, which is where we get the term hash. It has to do with how it's implemented underneath. Again, that's a real geeky rabbit trail that I'm happy to talk about off stream. But so it uses its own internal ordering. So although it's in the right order that we added it right now, there is no guarantee. So there is no implied ordering in a dictionary. You could run through it 1,000 times and it could be the same, and the next time it could be different. Now, practically, that's not going to happen, but the developers that implement a dictionary, there's this contract that says there's no implied order. So don't write your code so that it requires the order to be a certain way. If you want to do that, then you need to do other things like pull out all the keys, then order those alphabetically or something like that. But just pulling it out like this, there's no implied order. Okay? Now, if I wanted to access a particular one, I could access it just like we would with a string or just a list. And we can go and it pulls one out. I'm putting spaces here. Python doesn't require spaces. Most people don't. Again, I do a lot of programming in front of other people that are trying to learn. So I've gotten into a habit of trying to improve readability. And so I'm really trying to emphasize the key in this place. So that's why I do spaces. So I'm all about readability, mostly because for 17 years I programmed in front of other people and readability was important. So you don't have to do it, but if it helps you, then by all means. So there's some things we can do with dictionaries. So first of all, just like a list, I can get the length of a dictionary. So I can say, what is the length of birthdays? Print 2 because I've got 2 things in there. And then it is an object, so it has methods. So for example, I can print all the keys or retrieve all the keys, or I could retrieve all the values. So notice that it gives it a special type of keys and then values. Underneath, it's essentially a sequence, so we could use for loops, things like that, to go through it. And again, just like a list, there's a couple of different ways we could go through this. If we just want the values, I could call the values method. If I want the key and the value, then I need to call keys, because I can get the value associated with a key, but I can't necessarily get the key associated with a value. And that's because there are rules involving duplicates. So are keys unique? Yes. So for example, in a dictionary, you don't have the same word listed multiple times. Now, you may have a word with multiple definitions, but that's where the value is actually a list of definitions. So that's kind of the end around. But you don't have the word or a name in a phone book, the exact same thing in there twice, unless you have like John A. Smith or something. But they're still separate, right? They're distinct people. So keys are unique, but values are not, which means I could go in and I can create a bunch of different birthdays with people with the same name. So the birthday here has to be unique, but the value associated with it is not, which is why it's not always possible to get like Steve's birthday if there's multiple Steves, right? It depends on which one you mean, and I don't have enough information. Okay, so that's one thing you have to consider. There are some implementations of dictionaries that allow for duplicate keys, but those are usually specially designed to enable that. Most of the ones that come by default, in my experience in programming languages, do not allow duplicate keys. So the idea is, if I were to put in something with the same key, what would happen is that it would replace the one that's already in there. Okay, so when I pull it out, Sam replaced Steve. Okay, so it replaces the value in there. We basically stick that key. It says, oh, that key is already in there, and it replaces the value associated with that with the new one, and the old one is just lost. So if you want it, you have to pull it out first. So now, if I were to try and do something like this, then I'm going to get an error because the dictionary doesn't find that key in there, right? So I get a key error in this command, in this example. So you all have to make sure that that key actually exists. Just like if I were to try and pull, 55 out of here, it would error out and say that it's, past the end. So same sort of rules. It's just we've got different indices or keys in this case. All right. So you've seen a little bit of how dictionaries work. I mean, that's basically the functionality. But let's use it with a couple of examples so you can get a feel for how it's used. So when you want to find a definition for a word or a telephone number for someone, it's called a lookup, right? That's why sometimes you'll hear these called tables, because we called like a lookup table. Well, sometimes you want to do the reverse, like, when you get the phone call and you want to find out who's on the other end of that spam call, or the definition of a word, but you can't remember the word itself. In this case, what you're wanting to do is you're wanting to do a reverse lookup. All right, so it's easy to do a lookup in a dictionary, right? I just give the key and boom, I've got the value. But if I want to do a reverse lookup where I look for a key given a value, the dictionary doesn't support it natively, so we're going to have to do some different things. So the idea is we are going to look for a key given a value. So we're going to do the reverse. So let's write a function, and we're going to call it reverse lookup. And I am given a dictionary and then a value. Okay, and then I want to find the associated key. Now, I'm going to use none here. Notice this is not a string. There are not quotes around it. And idle here even colored it, used some syntax highlighting. And the idea here is that this is a special value, which means nothing, none. Other programming languages like null, that would be something you could, it's an equivalent, right? So now we need to just search for it. So this is like our default, and we could return key at the end. So let me look. I'm going to go ahead and use the birthdays one. So I'm going to print reverse lookup a dict, and I'm going to do Tony. And so that should return the 529. All right. So, I mean, I can run it now, and, oh, it's called birthdays. So I can run it now, and it's going to return none because I haven't implemented it. So let's start working through some of the things here. So I can't just, grab the value associated with the key, because that's the reverse of how things work. So what I'm going to have to do is I'm going to have to walk through each one of the keys and then check to see if the value associated with it is the one we want. So I'm going to iterate through all the keys, and then I have to get the value associated with the current key, and then say, does the value match the given value? And if so, yes, we found the key. Now, remember I said that values are not unique, but keys are. Well, what if I had 3 or 4 Tonys in here? Well, what this would do, it would find one and then say, yes, I found it. And then we'd have to say, do we stop? Right? Are we here just to find the first one? Do we want to find the last one? Do we not say which one? We just return one of them. And so at this point, we have no requirements. So we could pick, whatever one we want. What we'll just say that we're going to stop with the first one. And so I can say stop looking. All right. And so if you remember some of the loop stuff we did, you should have an idea of what we're going to use here. I said don't use it often, but this is one of those situations where you can. All right, so let's talk about it. So how am I going to go through all the keys? Well, I've got this keys method here, and I mentioned that it returns a sequence. So I can do something like this. So I can say for key in adict.keys. And so what that will do is it'll return all the keys and allow me to go through one by one. And so they can say, I want to get the current value. And so this is adict key. So get that. And then say, does it match? Right? And so if current value. Now, we have 2 options here. So I've got to do the value, and I've got to see, do they match? So I could use equals equals, right? But what we said, if you remember back, it doesn't necessarily check for equivalence. It checks to see if it's the same object, which if it's a string, we're good. But if it's not a string, this isn't what we want. We may want to choose if they are equal. right? And so let's go back. I want to show you what we did in the previous one, as a reminder of what we did. So let's see, where was that? I think it was in this one. Aha. So objects and values. Oh, it was is, not EQ. Wrong language. So this tested equivalence, this tested sameness. Oh, so we do want the equals, right? So we want to check equivalence to see if they're equivalent, not the same thing. Okay, so I had it backwards. So we found the key. So key is, actually, we can't use the same thing, so I'm going to have to rename this current key. Current key equals key. And then I want to stop looking so I can break. All right, so let me run through this real quick. So we have our key that we're looking for. We're going to iterate through all the current ones, all the keys. So we've got our current one. We get the current value associated with the current key, and then we check to see, is it equivalent to the value we were given? If so, then we found the key we were wanting. We can use a break to stop looking. So let's run this here real quick. And I still get none. All right, so we've got to figure out what's going on. So this is where we can use scaffolding and debugging code. All right, so I can say something like here, print checking key equals current key, and then print current value is value. Then I could say print it matches. And I'm doing a little space in there so it's a little bit easier for me to see. All right, so let's run through this. So it's checked 0704, and it matches. Oh, we get the match, and we can see here, oh, I made a simple mistake. I reversed these. So what I really need to do is write it like this, and then we get the correct key. So I had it backwards, right? Because I was swapping the keys, the variable names back and forth. So this is how you would write scaffolding code, with the idea of being able to track your progress. So again, if you program more, what you'll probably move to, instead of print statements, we'll move to a logging system with debugging logs. And so since I don't want these in my final product, I'm just going to comment these out. It works. Now, I could get rid of it, or I could keep it in here. I'm going to keep it in here for the moment, just to see, in case I were to ever need it, further development. Okay. Before we go on to the next example, Emmanuel Molina's got a question. Can we use numbers as a key value? So let's try it, right? It won't really make sense to do it for birthdays, but let's do something else. So I can say this is a test dictionary, and so I want to have 42 is the answer, and 13 is bad luck. And then let's print test dict. Okay, so it works. That's the nice thing about programming languages, especially when you're trying some simple things like this. You're really not going to break the computer if you try it. And if it complains, then the error message usually will give you an idea of what's going on. Okay, so this is a reverse lookup. So we're kind of using the dictionary backwards. not how it's intended to be used. Again, dictionaries are designed to be used like this. That's the way they function the best. It's, all the complicated stuff happens underneath the hood, which you don't need to concern yourself. It's just, it works. But sometimes you need to do that. Now, there's another thing you may need to do. And so you may need to do, well, let's talk about dictionaries and lists here for a second before I go on. As I said, in an actual dictionary, some words will have multiple definitions. And so what may happen is, especially on birthdays here, we may have, very likely, multiple people with the same birthday. And so do some print stuff here so we can kind of see what's going on. So I've got birthdays. Do some more. And so I can have it equal a list. So these are all the people with birthdays on July 4th. And so I can print birthdays now. And you can see we still have Tony as 1, but then Steve, Sam, and Nick are a list. So you can have, what I'd do if I were designing this for regular usage, I'd make this a list with just one thing in it. So all the values are the same data type, because that would be problematic if they're not. So let me create a dictionary here. So I'm going to copy and paste because it's kind of tedious to type all of this out. So this is a dictionary, and I can just call this my phone book. Okay? Because these are names and numbers, right? And so you can see some things here. So Bob and Molly have the same telephone number. For example, they're married and they have the same house number. And Fred and Sally have the same house number. And so if I wanted to do like a caller ID for my phone or something like that, what I'm given is the telephone number, and I need to find the name, right? So basically a reverse lookup like we did. But instead of having to do that reverse lookup each time, I'd like to pre-compute that. So I'd like to make a new dictionary that has the telephone number as the key, and then the name or names as the value. And so what this is called is inverting a dictionary. And so the idea is you take the keys and make them values, and the values and make them keys. Now, the challenge here is that we have, while keys are unique, values are not. And so when I go to invert it and swap it out, I could have both Sally and Fred. And so what we need to do is we need to make a list just like I did here. All right. So the idea is we're going to swap them, but we're going to build lists for the new values, because it's potentially I could have more than one. All right. So I'll explain it as we go. So I'm going to do invert dictionary, and I'm given a dictionary. Okay. And I'm going to create a new one. I'm going to call inverted, right? So I'm not modifying the original one. I don't want to modify the original one. And so I can return inverted. And then, so for example, if I wanted to print, or here, I'll just do this. Inverted phone book. And so I can say invert dictionary for phone book, and then print inverted phone book. I should, once I implement this, get something where the telephone numbers are the keys, and then a list of names is the value. All right, so we're going to have to figure out how do we go through this. So we've got the keys, right, from the starting dictionary. So we're just going to have to iterate through the keys in the original dictionary, because from that key we can get the associated value, right? So let's get the associated value. And so we're still in the original dictionary. Now, we need to start putting this in the dictionary. Where we put the value of the original is the key in the inverted. But we're going to need to, we've got kind of two options, right? So the very first time we come here, there is not already a key in the dictionary for this telephone number. So we're going to have to build it, and we're going to make it a list to handle more than one. The second time we come across this key is already in there. We've already created a list. We just need to add to the list. All right, so we've got two situations where does the value exist as a key in the inverted dictionary, right? If not, or when you say yes, add the key as a value to the inverted dictionary. Otherwise, no, we need to build a new list and add it as a value to the inverted dictionary. Let's see, yeah, add it as, build a new list with the key and add it as a value in the inverted dictionary. All right, so let me walk through the algorithm here just as a reminder. So we're going to walk through all the keys. I'm going to grab Bob. Then I'm going to get the value 1, 2, 3, 4, 5, 6, 7. And then I'm going to say, does this value 1, 2, 3, 4, 5, 6, 7 exist as a key in the inverted dictionary? The first time, no. So what I'm going to do is I'm going to put Bob in a list and add it as a value in the inverted dictionary with 1, 2, 3, 4, 5, 6, 7 as the key. Then I go on to the next one. I grab Jenny and then 8, 6, 7, 5, 3, 0, 9. That is not a key, so I'm going to add Jenny as a list in the phone book. Then I come across this one. Let's go on down to Molly. I've got 1, 2, 3, 4, 5, 6, 7. Yes, it already exists. And so I'm just going to add Molly to the list that has Bob. All right, so when I get done, I should have 1, 2, 3, 4, 5, 6, 7 as a key, and then Bob and Molly as values, and 9, 8, 7, 6, 5, 4, 3 as a key, and Sally and Fred as values, and then 8, 6, 7, 5, 3, 0, 9 with Jenny as a value. Okay, so let's start implementing it here. So I'm going to do for key in a.keys, okay, and then I get the value key. Now I need to check and see does the value exist, right? So if you remember when we did the string, right, we could say, is this character in the string, or is this value in a list? We can do the exact same thing here. So for example, I can say if value in inverted, and it'll check to see if value is a key in inverted. If it is, then I know that this is a list, right? And so when we talked about, it was either last week or the week before, if we just want to add something to the end of a list, we can use append. And so I append the key. Else, so it's not in there, so I need to actually build a new string in the, build a list in the dictionary. So I'm going to say inverted value, and I need to put a list in there just like we did here. So I'm going to do build a new list with a key and add it. All right, so let me run this real quick and see if we get it out right. So I've got 1, 2, 3, 4, 5, 6, 7 with Bob and Molly. Bob and Molly have that phone number. 8675309 is Jenny, and then 9876543 is Sally and Fred. Okay, so it worked out. And what we can do is we can put some debugging code in here because I know that this might be a little convoluted. So let's put some stuff in here to help understand what's going on. So I'm going to call this current, and I'm going to put key, then an arrow, so we can see what the current one is. And we can see here that print key already existed, or here, value existed as a key, added key as another value, or value did not exist as a key, added key in a list. So if we run it now, we can see I had Bob 1, 2, 3, 4, 5, 6, 7, the very first one. It did not exist as a key, added it to a new list. Same thing with Jenny and Sally. But once we got to Molly, 1, 2, 3, 4, 5, 6, 7 did exist. And so then what we did, we added Molly as a key to another value, which is why it comes second after Bob. And then Fred was the same thing. It was in there. And so we added Fred after Sally. So the list stays in order. And it just so happened that it printed this kind of in the order they were added, but we kind of get lucky and it's not a guarantee. But I know as soon as I try and demonstrate that it's not a guarantee, it'll always match. And then as soon as I'm, assume that it does match, it won't work for me. So, Emmanuel Molina's got another question. Can you build the list by just appending the value? So I append it to an existing list here. I append key. I have to do it this way here because at the moment, there is no key value pair associated with this key because it doesn't exist yet. And so if I just put regular key in there, it's not a list, it's just a string. And if I call append to it, it's going to fail because append is going to assume there's a list. So I have to create a list here. Now, I could have just created a list and then appended it the same way. So there's a couple of different ways I could do it, and that way may be a little bit more efficient. But I'm trying to be very intentional about separating it since there's two separate cases here and people are learning. So there's an alternative way to do it. If you'd like to see it, I'm happy to show you in chat or something like that. Okay. But what we did was we just inverted a dictionary. So we took a normal dictionary and swapped the keys and the values, right? This doesn't happen that often, but it does happen often enough that it's good to know. And if nothing else, it just helps you understand how dictionaries work and how to process them and how to use them. So that's the end of this talking about dictionaries. I'm going to pause, or I'm going to kind of ramble for a second. So if anybody has any other questions, I'd be happy to answer them. So next week is the last week. We're going to cover tuples. Now, if you look at the book, there are many chapters past chapter 12 that are in the book. So historically, I've stopped here. One, because when I teach in a semester, I run out of time, right? I'm able to just get this amount of content in the semester. In this case, I'm not necessarily constrained by that. But the first 12 chapters, I think, are enough to get things under your belt that If you're just going to be doing some minor programming in a little bit, this is kind of the basics you need to get going. If you want to learn more, you've got a strong foundation now that you can go through the rest of the book and other content, and you can learn it on your own if you're motivated, or at least get to the point where you can ask intelligent questions, or questions based on some fundamental understandings. So we're going to stop at chapter 12. So next week will be the last week. So again, happy to answer questions and things like that. But so please join us for the last one. Tuples are pretty interesting. You can use them in a variety of situations. They're kind of like lists, but immutable. And we use them for different things. So it'll be jam-packed. Sometimes it takes quite a bit of content, so I probably won't hit everything in the chapter, but it won't be enough to warrant another stream. So we'll just kind of hit the high points and go from there. So I'm not seeing any more questions. So again, I want to thank you for joining us for this evening. If you have questions, please feel free to ask in Discord, and look for my post on Monday for the last algorithm of the week. And I will see you next week for our last episode. Thanks, and see you later.